is Kevin Rossi, and I'm going to talk about a term that you would see in an introductory statistics class. When I taught statistics at Kishwaukee College in Illinois shortly after graduate school, people like that I use examples that have everyday words in them, things that people can understand and conceptualize. One term that you're going to see in a statistics class is standard deviation, but people say, what is that? What does that mean? And what does it mean to me? When am I ever going to use that? Okay? So I'm going to have 3 different examples here because people often remember stories. If I was going to go bowling with you, this is my bowling ball over here, these are my bowling pin. If I was going to go bowling with you, and maybe I'll go with my wife too, and you're going to bowl, and you ask me, what score do you usually get when you bowl? Like, what kind of bowler are you? I would tell you my average score is 120. So if I go bowling with you, are you going to expect my first game to be 120 and my second game to be 121 and my third game to be 119? Probably not. If my average score is 120, I should also tell someone I'm going to bowl like 120 plus or minus 30 points. I might bowl a 147. My next game I might bowl a 132. My third game, if I'm getting tired, I'll bowl like a 93. Okay? So if I told you I usually bowl 120 plus or minus 30 points, then that next number I give you after saying plus or minus, that is like my standard deviation. So let's say that a little over 2/3 of my games are within that range. What's that range? From what number to what number? 90, 120 minus 30, up to 120 plus 30. Somewhere in that range. So, if I bowled every day for years, and let's say that a little bit over 2/3 of my games were in this range, let's say 68.2% of my games were in this range, then 30 would be my standard deviation. Now that wasn't a statistics problem. I didn't give you some information and ask you to find something different. I gave you all of the data, I gave you the answer, what the standard deviation was, because I'm just trying to demonstrate the concept. For my next example, I'm going to use this bus. When I was in graduate school, I had the opportunity to go to China. It was a lot of fun. I taught English at a junior college, and while I was there, I got on a bus. Before I got on the bus, I said to the bus driver, 多少钱, which means, how much is it? And the bus driver told me 5 cents in Chinese. So I said, 可以,谢谢,再见, which means, oh, okay, thank you, bye. And then I stepped onto the bus, I gave him 5 cents. While I was on the bus, I noticed this bus was not built for me. I had to stand in a place on the bus where there was an opening in the bus. This was kind of like a sunroof on a car, and it was to offer ventilation so air could go in and out of the bus. While I was standing in the bus, I could see above the top of the bus in each direction, and everybody on the bus was staring at me. It was funny. I felt like a giraffe. The whole trip, funny things happened everywhere I went. I'm 6'1". It's not like I'm 7 feet tall, putting a hole in the roof on the bus. So that was already open before I got on the bus. So I noticed I'm taller than the people there, but not only am I taller than the average people in China, but also the people that I did see there, they were closer to the same height. Out of Chinese males, you will find that their average height, Chinese adult male, is 5'6", which is 66 inches. Can you guess the average height of an adult male in the United States? It's 5'10". And you can look that up if you don't believe me. But you'll notice if these are the different heights of different males in this country, and here's different heights of males in China, you'll notice that there's a wider spread here of where a lot of the males fall compared to in China. So if the average is 5'10", that's the same as 70 inches, and the average there is 66 inches. Here's 70 and here's 66. But I'm going to tell you that the standard deviation here, most males are 70 inches plus or minus 3 inches. So what would that range be? From 70 inches, what number would I go up to and what number would I go down to? I'd go up to 73, I'd go down to 67. Okay? So if the true standard deviation of the entire population of adult males is 3 inches, then that means 68.2% of the population should fall within this range, 67 to 73 inches. So for males in China, if the average is 66 inches, the standard deviation is 2 inches. So if 66 is in the middle of that range, then what range should I expect to find 68.2% of the population? Somewhere between 64 inches and 68 inches. Again, I didn't say everybody's going to fall in that range. You're going to tell me you know somebody who's 6'4". Okay? You can see a tall person here, you can see a short person there. But this is where a little over 2/3 of the population will fall. For my third example, I have the amount of time that it takes me to make a frozen pizza. I have to preheat the oven, I have to heat the pizza, and then I also need to wait for it to cool. So if I was going to make a pizza, and let's say I made a pizza every day for the last 5 years, every single day I made a pizza, and I had the amount of time it took me each day for the entire process. So there's some variance in how long it takes to heat up the oven. I don't know why. Sometimes the pizza just cooks a little bit quicker. So let's say it took me 20 minutes one day, 19 and a half, 21 minutes, 20 and a half, 18 minutes, 19, 21 and a half, 20 minutes. Okay? I want to represent this population to someone. This here, that's my pizza. If you can't see it really clearly on your computer, or if you're looking at this on an iPhone, you're not missing much at all. It's just a bunch of dots. I don't know how to draw a pizza. So the average here is 20 minutes. If you're asking me how long it takes me to drive to work, I will tell you it takes me 20 minutes. But when I'm driving to work, I'm not going to get there in 19 and a half minutes or 21 minutes or 18 minutes or 19 minutes every single day in a tight range like that. There is more of a deviation. I might get there in 27 minutes if I hit a lot of stoplights and there's some traffic or an accident. It might take me 19 minutes. It might take me 15 minutes if I catch every green light. I don't catch any stop signs. People are not on the road in front of me. 18 minutes, 22, 27, 16, 15, 19. So the average of these numbers, let's just say this goes on and on. For years, I'm just looking at my commute time to work every single day. I might say it takes me 20 minutes, but it'll take me 20 minutes plus or minus 4 minutes. Over here for cooking the pizza, when's dinner going to be ready? 20 minutes plus or minus 1 minute. So does that mean that 99.99% of the time I am going to get the pizza cooked between 19 and 21 minutes, just going one standard deviation above and below this average? No, it doesn't. You're going to see a 21 and a half here. You're going to see over here for commute time, it's not always going to be, it's not 99.9% of the time going to be within 4 of 24. All these numbers are not between 16 and 24. You're going to see a 27 here. You're going to see a 15 here. Okay? But with a huge sample of data representing the entire population, or if I had every observation, if I had thousands of observations, you're going to see that if the standard deviation is 1 minute on the time that it takes me to cook a pizza, then you'll see 68.2% of my observations all being within 1 from this number, because that's the size of the standard deviation. And over here, you're going to see I am going to have 68.2% of my observations to be within 4 minutes of this average. Thank you.